Right, so question 3 is sequences and series, and we've got a pretty tricky one here. Basically, if you try putting in some values, you'll find it hard to spot what the actual series or sequence is in this case. And the reason why is it's actually 3 separate series all added together. So the first one, if we kind of split up each bit into 3 parts. The first bit is just the sum of the number 3 16 times. So we're going to get 16 times 3. So that's our first bit of this series. Second bit, 5r. This one is going to be an arithmetic series, and we can kind of prove that over here by putting in r equals 1 and r equals 2. So we're going to get 5 lots of 1 plus 5 lots of 2 plus 5 lots of 3. So 5 plus 10 plus 15. So that's an arithmetic series with a first term, sorry, U around there. 3 or 8. Sorry, first term A is going to be 5, and the common difference is also 5. So we've got our arithmetic series there. So if you want to work out the sum for this one, we're looking at n is going to be 16. So our sum of 16 terms is going to be n over 2, 2 lots of A, plus n minus 1, 15 lots of the common difference, 5. So if we work that one out, we get 680 for that bit. And the last bit is going to be a geometric sum, and I'll show you why over here. So 2 to the I, if we put in some values, we'll put in 1, we're going to get 2 lots of 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3, etc., which gives me 2 plus 4 plus 8. So this is a geometric series with the first term 2, the common ratio is timesing it by 2, and again n is going to be 16. So to work out the sum for the 16 terms, we use our sum equation, 1 minus r to the n over, over 1 minus r. Take 2. So if we work out that one, which gives me a big number, 131,070. So it wants me to add all those together. Write that a bit clearer. There's 70 on the end. So adding up these, we've got 16 times 3, which is 48, plus 680, plus 131,070, which gives me 131,798, which is what they wanted me to show. Right, part 2 is completely disconnected from part 1 there. So in this one, we're asked to find the sum of the first 100 terms. So it's going to be a lot. We've got to figure out what's really going on. So our first term is 2/3, and we've got the recurrence relationship that the next term is the reciprocal of the first term. So if u1 is 2/3, basically if you're ever stuck, put some values in and find the first few terms. So the second term is 1 divided by the first term, which is going to be 3/2. The third term is going to be 1 over that, which is back to 2 over 3. So you can see our sequence is going to kind of reciprocate each term. We're going to get 2/3 plus 3 over 2 plus 2/3 plus 3 over 2 repeated. Now it wants us to find the sum of the first 100 terms. And in 100 terms, we're going to have 50 of this one, so 50 times 2/3 plus 50 of 3 over 2. So if we add those two together, that will be our sum. So 50 times 2/3 plus 50 times 3 over 2, which gives me 325 over 3. Cool, and that's it done.